Hello, Miss. Today we're going to discuss about PA Poisson distribution questions. So the first question is the number of planes arriving at an airport every hour during daytime is modeled by the random variable x with distribution PO 5.2. State the two assumptions required for the Poisson distribution model to be valid in this context. So the two conditions are the event must be independent. So which means each plane arrival does not affect the arrival of the others. And the planes arrive at a constant rate. When P, find the probability that the number of planes arriving in a 15-minute period is greater than 1 and less than 4. So the mean in 15 minutes is 1.3 because 5.2 is the mean for every hour. So if it's 15 minutes, so 5.2 divided by 4, which is equals to 1.3. And then the question is greater than 1 and less than 4. So Px equals to 2 and Px equals to 3. So then we will put e to the power of negative 1.3 times 1.3 to the power of 3 divided by 3 factorial plus e to the power of negative 1.3 times 1.3 to the power of 2 over 2 factorial. So after we count, we get the answer 0.330.
So next is 1C. Find the probability that more than 3 planes will arrive in a 40 minutes period. So for this one, we just find the mean of 40 minutes, which is 5.2 x to the power of 2 per 3 equals to 3.467. And then px greater than equals to 3 or equals to 3 equals to 1 minus px equal to 0 minus px equal to 1 minus px equal to 2 minus px equal to 3. So we just do 1 minus P0, 1, 2, 3, which we count with the calculator, and then we get 0.456.
Okay, so next we have number 1D. The airport has enough staff to deal with a maximum of 60 planes landing during a 10-hour day. Use a suitable approximation to find the probability that on a randomly chosen 10-hour day, staff will be able to deal with all the planes that land. So, because we know that it's 10-hour period, we know the mean or the NP is 52 from 10 times 5.2. Because this is a Poisson distribution, NP equals variance, so it's also 52. And the standard deviation is the square root of the variance, it's square root of 52. To find the suitable approximation, we can use the normal distribution because it's less than 60 or less than or equal to 60. We can approximate to x is less than 60.5, and then we find the normal distribution value of 60.5 minus 52 over the standard deviation or square root of 52. And then we find that it's 0.88. Next, we move on to number 2. In number 2, the independent random variables x and y have the distributions Poisson 2.1 and Poisson 3.5 respectively. So now, for 2a, it is find p x plus y equals to 3. So, because both of them are independent random variables, we can combine them together to form the random variable z. And we have z is the Poisson distribution 5.6. To find z equals to 3 of the Poisson distribution, we just input it in the formula and we get e to the power of negative 5.6 times 5.6 to the power of 3 over 3 factorial is equal to 0.108.
So we need to answer to B, which is given that x plus y equals to 3. We need to find the P of x equals to 2. So using conditional probability, we can answer that the answer to px equals to 2 given that x plus y equals to 3 is px equals to 2 times py equals to 1 over pc equals to 3. And you can just input it inside the formula to get 0.264. For 2c, there's a random sample of 100 values of x, and we need to find the probability that the sample mean is more than 2.2. Since there are 100 values of x, so the n is 100, and the mean of 100 values of x, which has a mean of 2.1, is 210. And since it's a Poisson distribution, you can approximate it, and so the variance is also 210, which means the standard deviation is standard square root of 210. So we can just find the normal distribution of x greater than 220. And so we can, by normalizing the x, we can use 220 minus 210 over the square root of 210, which is standard deviation. And then we might 1 minus the value of that, which is 1 minus 0.755, which is equal to 0.245. That concludes our math presentation. God bless you. Thank you.